The lesson topic for this video is, I can determine the domain and range of a radical function. So first of all, let's define domain and range. The domain of a function is the set of all possible x values in the function, and the range of a function is the set of all possible y values. So again, that means that the domain is the x values that are true for this function that are on that curve when you draw it, and the range is all the y values that would be on the curve, the possible y values. Now when we see the graph of, let's say, a square root function, I'll draw one on here. Let's say we have the starting point on the origin at 0, 0, and it graphs up like this. That was our parent function. If we look at this right here, we only see a portion of the graph, right? Because this arrow tells us it continues up and to the right. So the question is, what is the domain of this curve? Okay, now we're not paying attention to the graph paper or the coordinate plane shown. We're just looking at this red curve right here. What are all the possible x values that are on this red curve? Well, as you can see, there are no x values on the curve to the left of 0, because the starting point for this curve is right here. So the leftmost x value that we could have for this curve right here, the leftmost x value is 0. But the rightmost x value, well, the rightmost for this red curve, because it has an arrow showing that it extends forever and ever and ever and ever and ever to the right, forever, that means the possible x values for this red curve goes infinitely forever to the right. So when we talk about domain, I often will say, think about it as being the leftmost values of x to the rightmost values of x. Okay, so the leftmost to the rightmost values of x. And then to talk about the range, we would talk about, again, we're talking about the set of all possible y values. So if you think about this, again, red curve here, what is the smallest y value that we could have for this curve? Well, that would mean the lowest point of this red curve. Now, the lowest point of the red curve is right here, again, the origin, because there's no y values down here. Okay? So the lowest y value on the y-axis, the lowest y value is 0. And then what is the largest or highest y value? Well, again, this curve is going up and to the right infinitely. So even though it's kind of slowly going up, it will continue to go up infinitely forever. Again, a much slower up than it would be going to the right. Right, it's going, the x values are getting larger quicker, but the y values are getting larger and larger and larger infinitely. So we can think of the range as being the bottommost to the topmost values of y. Okay? So the bottommost to the topmost values of y. What's the lowest y value, and then what's the highest value, y value? So how do we write the domain and range? Well, this is what we use. We use a series or a set of parentheses and brackets to help us write them. So let's first talk about the domain of this red curve right here. Okay, so what is the furthest left point on the x-axis? Well, we don't have any negative x values. We have 0 as our smallest x value. All right, now 0 is a specific number, so we're going to use a bracket on the left and put a 0. Okay, 0 is the leftmost x value that is included on this red curve. And then we write a comma. And now we're going to write the rightmost value of x. Now we already talked about this. This curve goes forever to the right, so it's infinite. So we use a symbol for infinity or infinite, and that is a sideways 8, like so. And anytime we go infinitely, we're going to use, instead of a bracket, because a bracket is for a specific number value, we are going to use a parenthesis. So the domain, which we usually use capital D to represent, the domain of this function looks like this right here. Now how about the range? Well, the range of this function, again capital R, we need to think about what the bottommost or lowest point on the y-axis is for this red curve. Again, y-axis is here. Are there any points for y that are down here? No. The lowest y value is 0 right here. The lowest value is 0. So again, we're going to say 0 for our range. And then what is the topmost value of y? Well, this curve, even though it might be slowly going upwards, it is going up forever to the right. It's going up and to the right forever. So we are going to again use infinity, and we can close that with a curve. So there are a lot of different ways that these brackets and parentheses can end up being used depending on which way the curve goes, and we're going to look at some of those options on the next screen. Okay, so let's take a look at a couple of examples that I've already graphed, and we're going to write the domain and the range for the function. Okay, so if we take a look at this first one, we have the negative square root of negative x plus 5 minus 3. So as we've talked about in previous lessons, we're going to first factor out the negative. When we factor out the negative, we end up with x minus 5 in the parentheses and minus 3. So we know our starting point is 5, negative 3. So I put that point at 5, negative 3. And then it opens down and left. So this is down and left. All right, so what is the domain of this function? Now remember, domain we can think leftmost to rightmost. We'll take a look at where the arrow is pointing. The arrow is pointing left. It's going forever in the left direction, which means that it's heading on the x-axis towards negative 10, 11, 12, 13, 14, all these numbers, so on, forever to the left, which means it's heading towards negative infinity. So our leftmost point, well, there isn't a leftmost point because it goes infinitely to the left, but it tells us that our domain goes to negative infinity on the left. So again, we use the parenthesis, not the bracket, because anytime you have a infinity or a negative infinity, you're going to use a parenthesis. Okay? And so that's the leftmost. It goes forever to the left. Now, what's the rightmost value of x? Well, here's the x-axis. What is the rightmost value of this curve? Well, the rightmost value is 5. So 5 is the number here, and it's going to have a bracket because it's a specific ending point, or a specific rightmost point. Okay, now how about the range? Well, again, to determine the range, we're looking for the bottommost y value to the topmost y value, the lowest y value to the highest. So again, if it's curving left and down, the lowest y value is going to continue going down forever, which again is negative infinity. Oops, there you go. And the uppermost or topmost y value, well, the topmost y value, here's the y-axis, right? The topmost y value is negative 3. All right, so negative 3. And we close that off with a bracket again because it is a specific point. So there's our domain and range for this function. Now let's try this one over here. Now this time we have a cube root function. See the cube root right here. Because the sign at the front is negative and the sign by the x is positive, they have different signs, so it's decreasing. So it's higher here and lower here. And then we know that our inflection point is at 1, 2. So that inflection point is at 1, 2 right here, and it's decreasing. Well, let's think for a second about our domain and our range for this cube root function. Domain, leftmost to rightmost. How far does it go on the towards the left? Well, infinitely to the left. How far does it go to the right? Well, infinitely to the right. So this is an example of when it goes from negative infinity to infinity. Now, how about the range? The range is the y values that are true for this function. Well, again, this curve goes up and to the left forever, so it's going up forever this way, and it's going down forever this way. So, what is the range? Well, the lowest most point, because it's going down, is again negative infinity, and the uppermost point is infinity. What do you think will be true about all cube root graphs? Well, their domain and range will always be negative infinity to infinity, both, because the arrows go infinitely in both directions anytime we graph a cube root function. Okay, so for these examples, we're going to find the starting point or the inflection point. We're going to state the direction of the curve, we're going to draw it, and we're going to find the domain and range. Typically, I would sketch it before finding the domain and range, but it's your call on that. Okay, so first of all, our HK for this function to find the starting point or inflection point. This is going to be an inflection point because it's a cube root function. And the inflection point is -2, -3. Again, we didn't have to factor out a negative or anything, so this one's ready to go. And it's the opposite of this, so -2, and it's exactly this, -3. The curve. Well, since the exterior out here is positive, and the x is positive, it didn't have a negative in front of it, it's increasing because they are the same sign. So it's increasing. So we go to -2, -3, and put a point. And then it's an increasing cube root function, so we're going to be increasing this way. And then at that inflection point, then we're going to change our direction of our curve for our half of a sideways parabola to go the other way. Again, as we mentioned on the previous screen, the domain and the range for this function, because it's going left forever and down forever and up forever and right forever, is pretty straightforward. -infinity to infinity for both. All right, the second one. Well, this time we do have a negative in front of x, so we need to rewrite the equation before we decide what the starting point is. So we factor that out, and then we write x -3, because we factored out a negative, -1. So our starting point, and this is a starting point because it is a square root graph. Again, we don't put the 2 here like we put the 3 here, but the 2 is assumed when there isn't a number, so it's a square root. And we have 3, -1 for our starting point. Opposite of this is 3, exactly this is -1. Because A is positive, we know it's going to open up. And because this negative right here is there, we know it's going to go left. Up and left from 3, -1. So 3, -1 is right here. And it's going to go up and to the left. So it's going to curve like this. All right, so the domain and the range. Again, a lot of times it helps people to think about where that arrow is. Let's think about where that arrow is. The arrow means it's going left forever and up forever. Left and up. If it's going left, the domain is going to have -infinity because it's going negative forever. So the domain is going to have -infinity on the left. And if it's going up, okay, again, it's going up, that means the y values are increasing as we go. So that means for the range, we're going to have infinity on the right-hand side because it's going to go up to infinity. Again, bottommost to topmost, leftmost to rightmost. Okay? So, what are those other values? Well, the domain is the rightmost at this point. We need the rightmost value. The rightmost on the x-axis is right here, and that is 3. And then for the range, we need to know the bottommost. What's the lowest y value? Here's our y-axis. What's the lowest y value? The lowest y value is -1. Okay, I am just about out of time for the 15-minute video. So if you'd like to try these two, pause the video, give them a try, and then check to see how you did. Okay, here are the answers. Hopefully you got the domain and range and the graphs correct.